Recording stuff done. Okay. Everybody agree with that?
I was clueless.
Yes?
Yeah.
Okay, so let's get started. We'll rope it back up here to the top and go through the stuff we did before. So let's start with this. Renewable means
It's
reusable. Name some.
Water.
Hydroelectric, solar, biomass, wind,
Wind. Thermal.
Natural gas?
Thermal.
You did this one.
Geothermal.
The
Geothermal.
That's what I was talking
You did this one.
Oh, the hydrogen?
Hydrogen fuel.
I thought that was like technically not.
Okay.
It technically is, and it's not.
So,
It's confusing.
We'll talk about it.
between.
Define non-renewable.
Not reusable.
Can't replace it, right? Not reusable necessarily, but
Not
replaceable.
replaceable.
All right, and identify as many as you can.
Fossil fuels.
Fossil fuels.
Nuclear.
Can't put that back together. Okay, what is the rate of consumption in terms of resources? Your rate of consumption.
How fast you
How fast you use it, you consume it, right? Consumers consume things. Now, what does the following graph show?
How much energy like the countries use
Yes.
Per person.
Per person, but what about the countries in particular? The higher level ones versus the lower level ones.
It's
the
like
developing ones are using
development.
Developed ones use it more, or have more energy. Undeveloped ones use less, because they primarily use what for fuel?
Wood.
Biomass. In terms of what we primarily use, 80% of our energy comes from fossil fuels, right? Of different types. Gas, gas, solid, and liquid, right? Liquid, solid, gas, different types, right? Let me see. As countries become more developed, they need more energy. The more energy they have, the more fossil fuels they have to use, right? If there's a shortage of oil, prices will go up. If there's a shortage, prices go up. Supply and demand, right?
Yes.
And if there's a surplus,
it will go down.
it goes down. Okay. Prices can be regulated though by governments using taxes and subsidies.
Okay.
All right. Which one makes it cheaper? Subsidies. Most underdeveloped countries use biomass like wood and charcoal to provide energy, especially warmth. In areas rich in plant life, bogs can form. What do you call that plant matter on the top? Peat, and then the layer below?
Lignite.
So from small words to big words, right?
Yeah.
So peat, lignite, bituminous, then anthracite. Which one's the best one?
Anthracite.
Because it has the most concentrated energy, right?
Yeah.
Which one has the worst? Peat. And then bituminous can be used for tar and stuff like that. Okay, now the cleanest fossil fuel is natural gas. Still makes CO2, just releases fewer other types of chemicals. We'll talk about next standard. If there's a lot of bitumen, that's where bituminous comes from, right? So we're talking about oil and fossil fuels. So if there's a lot of bitumen between particles of sand, water, and clay, they can be obtained and refined. These areas with all the sand and oil and stuff together we call
The
tar
Tar
sands.
sands.
Remember I said bituminous, right? Coal, right? We use for make tar. And so where we have bitumen in the sand, it makes tar sands. Does that make sense?
Yeah.
Okay. Let me see. Oil has many uses, but first it has to be refined into different types in an oil refinery. Right? Okay. Most energy types work by heating
Water
into steam to turn a
turbine.
that will spin a
Generator.
and generate.
Electricity.
How does oil form?
Plant life.
Plant life. What kind of plant life?
Decaying.
Decayed what?
Algae, right?
Yeah, it's plankton. Oil forms in the sea from all the phytoplankton that fall, right? And zooplankton that fall and form on the bottom. Okay, that's where we get our oil from. All right, at the bottom of the ocean. All right, and then that rises up. So different places have oil because they used to be the bottom of the sea, but the continental drift moved them around, right? And otherwise we just have oil drilling in the sea. Like you actually see oil drill things going on the shore, off the shore. Okay, what's that? Okay. How does coal form?
Animal.
Plant life on land. Okay.
Yeah, that's right.
The Carboniferous period. It's called the Carboniferous period because there was a lot of plants. The whole Earth was hot, and as a result, you had plants over the entire. There was no tundra. It was just plant life because it was so hot until everything literally caught on fire and burned away.
Whoa.
Because there were so many plants, and the oxygen level was so high because there were so many plants. It was kind of insane. So keeping it going here. If you watch, there's a show I just saw called One Strange Rock.
No.
Have y'all heard
I've
that?
heard of it, yeah.
Yeah, no?
Talking about
Okay.
their.
I think it's on Disney Plus.
Yeah.
Anyways,
I think so.
on Nat Geo, the Nat Geo side, you should watch it. It's really, it covers a lot of stuff we got in here.
Okay.
Anyways,
I'm definitely watching it.
Continuing here with this, looking at this, what does this graph here show?
Where are we
Like
get our
producers
source of
of-
energy from?
Mhm.
Where we get our energy from, right? Where do we find oil, like petroleum?
In the Middle East.
Yeah.
Middle East primarily. What about coal?
In the United States.
Asia.
U.S., Asia. U.S. and China are the big ones. Okay, U.S. we know there's coal miners here, right? And then China's a big one. That's where they get most of their energy from is coal. That's why they have such bad what?
Weather. Rain.
What do we know about the?
Smog.
You know? Yeah, smog, right? Yeah.
Where?
Okay, and then they have natural gas where?
Russia.
Up in Russia and also in the United States. Remember we talked about those people in Pennsylvania,
Yeah.
right?
yeah.
Okay. Let me see here. And these are called coal and oil reserves. So that means like extra stuff you have still in the ground. That's what they mean by reserves. How much they think they can still get from the soil. All right. So we already know we talked about that. Bless you.
Bless you.
Thank you.
What does this equation up here show?
Wow.
Another rain.
It's carbon.
It's a I know what it is. Don't tell me. Don't tell me. Don't tell
It
me.
says carbon cycle,
Yeah.
combustion, and
Metabolism.
metabolism. So this depends on whether or not you learned this in number 1 biology or in number 2 in chemistry. Either one of these will make this easier. So if you know the idea of metabolism, this would be what equation essentially?
I thought it was an equation for combustion.
Yeah.
It is, but it's also, if you look at it carefully, an equation for metabolism. What do we mean by metabolism?
He's right there. Photosynthesis.
It's respiration.
Respiration.
C6H12O6, which we said was
Oh.
glucose.
Glucose.
Right?
I was gonna say sugar, but.
Added to oxygen, which makes the respiration to produce carbon dioxide, water, and
energy.
energy. Now, here's the thing. Combustion and metabolism are the same thing. If we want to find out how much energy a food has, you can actually put it in a can and light it on fire. And what you see is how much that can, right, with the food inside it, heats up water. They use a specific heat of water. That's how we determine how many calories are in your food. We light it on fire. Because the process for combustion, blowing things up, is the same as the process for respiration. You take something, a chemical with carbon, and combine it with oxygen. What's CH4 there?
Methane.
Methane. Very good. Did y'all learn that in chemistry yet? Yes?
Yeah. We just started doing that.
Okay, good. All right. Now,
Yeah.
keeping this on forward. So it shows combustion. It's just taking something with carbon and releasing carbon dioxide. Now, how is oil typically harvested from the earth?
Drilling.
Yeah.
Drilling, right? Where do they drill?
In the ground.
Anywhere and everywhere. Okay.
Oh.
The current administration just authorized drilling off the shore, off the coast of every single state, except Florida, because they complained, and so they let Florida off the hook. But everybody else is kind of stuck with it, even though they also complain.
Not Georgia.
Not Georgia. Georgia, we actually have oil drilling going off on the coast anywhere you can. Because where do we say oil forms?
In the ocean.
Yeah, at the bottom of the ocean, right? Exactly. Okay. Now, how is coal typically harvested?
You gotta go like coal mining and stuff in the.
Okay, we showed this already. We talked about types of mining. Give me a name of some types of mining we talked about. All right, we had strip mining, right? You know, all the mining stuff. So you had to literally dig it out of the ground. But strip mining is one where you like cut layer after layer, and there was coal revealed underneath when we looked at some of those.
Yeah.
Okay, how is natural gas harvested? Fracking, right? Underground, they use water and they inject it into the rock and use the water to crack the rock. It's called hydrologic or hydrofracking, hydraulic fracking. I'm not sure what the exact term there is, but they use water to crack the rocks and get the gas out. Okay, so that's how fracking works. You dig a pipe way deep down and break the rocks apart. Now, what issues can fracking cause?
Groundwater.
Natural gas.
Some groundwater intrusion, right? And you can also, which can cause problems for who?
The people
But
in the
people.
area.
Yeah, for the people. Okay, so you gotta be careful when you say that there's groundwater intrusion. Like if you have an FRQ about this, right? You can say that, but then you also have to say what the actual damage to people, the
Okay.
effect is too, right? And then what else do we have? What else do those people experience? Many earthquakes, right? Which isn't great.
Those
Now-
are like no.
You're messing with the bedrock underneath their feet, so that's not a good thing. When generating energy from fossil fuels, you can use a process called cogeneration. What do you think cogeneration is?
I did this on that thing.
It's like when you use one source and then like a byproduct of that is used to power something else.
Yeah, essentially. Co is a prefix that means together. So generating together. So in this case, we're generating power, right? But to generate power, we always have to burn something. Therefore, we create lots of heat. So you can use it to create power and heat at the same time.
Yeah, you'd be like, you're able to do things at once.
Yeah, two things at once, exactly. Now, describe the generation of nuclear power using uranium-235, control rods, steam turbines, and cooling towers. How do we generate nuclear power? Starting with what?
The
Uranium-235. We mine them and put them into
Little pods.
little pellets and then put them inside fuel rods.
Same thing.
It's okay, little pods, right? Put them inside fuel rods, right? And then where do we put those fuel rods?
underground.
Not underground.
No,
In the
in
reactor,
the-
the nuclear reactor, right? In the containment structure. One containment.
Containment structure.
That's the thing that exploded at
That's
Chernobyl, remember?
Yeah.
The containment structure? Or I didn't have one, I guess. It should have had a
Yeah,
containment.
that's why it exploded.
So anyways, so it's supposed to have a containment structure. You put it in there. And then with the uranium inside those pellets, you basically inject
A neutron.
a single neutron, which makes it uranium-235 an
Unstable.
unstable isotope, which means it
Electron.
It blows up.
fizzes, goes through fission. Now, electrons are not used in this at all. What happens is you take that uranium-235 and it splits into two new elements, daughter nuclei. There can be many types, but typically it's barium and krypton are the two. But the main thing is it also makes three extra neutrons
Yep.
that go flying out.
And
So
then-
each extra neutron hits another,
And it just keeps
And
going.
then-
and it keeps going, but it goes faster. It's exponential growth because you're multiplying by what each time?
3.
Three, geometric, if you will. Okay. For
Cool.
those who did algebra or whatever. But now what I want to talk about is this. So it goes through that and it starts going uncontrollably hot real fast. So we don't want that. So what do we use to slow that?
The cooling rod.
Control rods.
Control rod.
Control rods are inserted, okay? Because they absorb free neutrons. So as a result, they'll soak up the neutrons and prevent the reaction from going faster. Does that make sense?
Yes.
The problem with Chernobyl was when they put those control rods in, the tips were made of carbon because it was cheaper and they got stuck inside the fuel rod channels and couldn't go all the way in. So the reaction kept on getting faster and faster and faster because the control rods couldn't go all the way down.
Oh, that's why all the things were like, you know.
That's where all the things were like, it's getting hotter in here, getting hot. Watch out, be careful, and then it exploded. Let me see, what else here? Interesting story about It's Getting Hot in Here by Nelly. It's getting hot in here, so take off all your clothes. He actually performed that in the Middle East, in I think it was Saudi Arabia. But they have laws against what you can talk about there. So he could, when he sang a song, he could only say, "It's getting hot in here. It's getting hot in here."
That's embarrassing.
It was really funny. Keep it going.
He needed money.
The
That's
whole,
why.
the whole point, because they sang it. It's one of my favorite stories. But anyways, the whole point of the uranium-235 is to heat up water into steam, turn turbine, and generate electricity. But what are the cooling towers for?
To cool off the.
To cool off what?
The
The water, the steam, right? When you make steam, you need to turn back into water so that you can do what again? Heat it back up. Even coal power plants have cooling towers. But you need something to turn that water that was steam, right? Back into a liquid.
Yes.
Alright? So it cools those cooling towers.
So what's in the cooling tower? Like cold water?
It's just a pipe with hot water or hot steam in it. And as it hits the air, it cools. Yeah. And so you see lots of it looks like smoke coming out, but it's just
Water vapor.
water vapor,
A
steam.
water vapor. Okay. Cool.
So it's more sustainable that way. Now, the good thing about nuclear power is no carbon dioxide is produced,
Yeah.
right? But the problem is
It's not renewable.
it's not renewable and it's still radioactive waste when you're done. You have
Dang.
to take those rods. I do talk about it here. Okay, so what do atoms do if they're unstable? They decay, right? And that process is called radioactivity. And why do they do it? To become more stable, all right? So they eject these particles and become more stable. The major issue with it is that all that waste has to be stored somewhere. Now, if you remember the nuclear power plant we went to, the first thing they do with the old fuel rods is to put them where?
In water.
In water, right? And let them cool over a couple decades. That's the weird thing.
And then
Okay.
some of them put stuff in like mountains.
And then they take what's left, the stuff that decays over longer periods, have a longer half-life, because the shorter half-life particles are going to eject radiation real quick. So you got to put them somewhere immediately. And then the ones that go longer, that take millions of years and not thousands of years, right? Do you remember the time I said we could return to Chernobyl?
Oh,
Yeah.
no, but it was a long
The
time.
year 22,000. About
Oh.
the time we can return to live there. Because you still have those radioactive particles that have such a long half-life. It takes them a while to decay. So you got to put those ones in mountains. I think that covers most of that. Now, renewable or non-renewable?
Oh, no.
Non-renewable. What are the 3 instances of nuclear meltdowns?
Long Island, or
Chernobyl.
Chernobyl.
The one in Japan.
5 Mile.
Japan is known as
Hiroshima.
Fukushima. Fukushima, and then
I don't
your number, right?
3
Mile.
I said 5 Mile Island.
I heard
but
5.
That's not right.
Wait, was that in America?
What's that?
Was that in America?
Yes. So that was in Pennsylvania, I think. 3 Mile.
Pennsylvania.
So 3 Mile Island and Fukushima.
Fukushima.
What happened? Meltdowns.
Meltdowns, yeah.
No casualties, right?
Yeah.
Okay, that's what you're asking.
Meltdowns, no casualties. Now, people did get radiation poisoning or sickness. However, they were treated through the process. Why did Fukushima occur?
Tsunami.
Yes.
Tsunami, right? And how did 3 Mile Island occur?
You know, I don't know.
Just a malfunction, just some kind of malfunction or something.
Okay.
I don't necessarily know the actual answer to that. What was the only case where people actually died from it? Chernobyl. And why?
Because they used different
didn't use the
things.
proper.
They didn't use proper materials, and they were pushing it along, right, to move ahead in the party. Okay. Now, the consequence, of course, is that you can't return to Chernobyl anytime soon. And in Fukushima, you remember he went there in his little suit. Remember Derek Muller in the Veritasium thing that I showed you?
Yeah.
When he was wearing that plastic suit, he went to different places.
That hospital.
And he went to the hospital in Pripyat, which is in Chernobyl, but he also went to Fukushima in Japan.
Oh yeah.
And he had to wear a mask, and he was like, I need to wear this mask, or I need to leave because I've been here a little too long. He showed all the stores
It
and
was
stuff.
recent.
Yeah.
Because it was recent, yeah. So you still have lots of radioactive material that hasn't decayed yet, with shorter half-lives. Okay, now, this one right here. Do you want to do this problem?
Yes.
All right, good luck.
Oh, no. I thought you meant together.
LOL.
Good luck, you got it.
That's right.
Oh, all the 8th graders did.
Yeah, they're good people.
There's one up there. There's one up there.
It was pink.
It's a gorgeous color.
Where's the curry?
It's a good question. So that's how the problem will be phrased on the exam. It used context. It shouldn't be too difficult.
It's just like a minute. Not a minute. Like a century. What is it? I'm trying to say like a gram. It's like it's the not a.
What do you need to be able to do this problem? Let's start with what you know you need.
Oh, look at you! You have too much stuff going on up there.
Give me loud.
Yeah, I could have been that.
Almost there. Yeah. Good.
Hold on.
That's how you learn. Is what right? Oh gosh.
Is this right? No.
Alright, so what do we get here? How much carbon-14 will be left?
10 grams.
10 grams. How many got 10 grams? Give yourself a high five.
Oh. I was,
What? Did you finish?
I wasn't.
Now,
Oh.
you didn't put grams.
I was thinking of something.
Yeah.
Carry
So,
on.
it's alright, we have 10 grams, but my question is, how long does this take?
17.
Okay, so what is
17,000. 190 years?
Yeah.
Okay, now carbon-14 is a really important radioactive element. It decays into nitrogen-14, so we use to tell how old human fossils are, because it's got a nice little sweet spot there with 5,730 years on its half-life. But the big thing is this, when we look at this, what are Curies?
Like cycles, like half-lives?
It's a half-life.
Half-life, yeah.
It had to mean something, and that's the only thing that makes
Three
sense to you,
half-lives.
right?
Yeah, I didn't
Yeah.
That is.
That makes sense.
Does that make sense?
Oh, so maybe
Okay.
we could have just.
But
Why didn't you tell me that?
what because you could kind of figure that out. There's no other way you can solve this without knowing that. Now, what I will say is, after 3 Curies, why is it called a Curie?
I'm really not sure.
We actually already talked about this somewhat too.
Oh, really though?
Mm-hmm.
That's
When we went in the Veritasium video that I showed you, he went to a woman's laboratory who won Nobel prizes in physics.
Oh,
and chemistry.
that lady.
Marie Curie.
Marie Curie.
Ding.
And she's the one who died from radiation sickness and poisoning, right? Because she was messing around with uranium.
And wasn't
All
even
over her desk.
And all over her desk and all over her
Chair
stuff and
and-
chair and everything, right?
Dang.
Did I tell you how the person who invented X-rays died?
Yeah, they
Oh,
He
because
did
she
it on
got.
himself all the time.
kept doing it.
There was another woman, and she was doing a
Yeah.
whole lot of experimentation on
Women,
herself.
am I right?
And yeah. So,
Oh well.
but you know what? Women can make dumb mistakes just as much as men can.
Oh, men can make
No.
plenty more.
No.
If I'm being honest.
Just as
No,
much. We're
that's not true.
gender equality,
Wait, no.
right? Gender equality for mistakes too.
Ew.
All right. Now, if
That's
you
an
would,
oxymoron.
what is biomass?
Like
Biomass is the
Like corn.
Corn?
No.
like
No.
dead,
Oh,
like
yeah.
organic
Yeah.
matter.
No, what you
Organic
use to
matter.
Organic matter used to
Corn
power
to
things,
make-
right? What do we use corn to make specifically?
Ethanol.
natural gas.
Ethanol.
Ethanol.
Oh, natural gas. Ethanol. Natural gas and gas.
It was
Fossil.
bouncing around there.
But you're good. It's all right. It's all right. That's why we say it out loud to make mistakes now, right?
Cause
Be an active learner. Make mistakes and be uncomfortable. Okay? Did I tell you that story about being uncomfortable?
No. Can I tell y'all a funny story? real
Miss
quick?
Manning does that
No,
too.
it's gonna take longer than we do.
But her poster looks like it says being uncomfortable.
Bean.
But before you get to your story, we watched a video on this, and in it said if you want to think and remember things better, you have to train your brain to be uncomfortable. And so after
That
I watched
is
the video, I told all of my 8th grade students, I want all of you to be uncomfortable, or I'm going to make all of you very uncomfortable. I said something along those lines, and then we all like looked at each other, and then we just started laughing because I didn't realize what I was saying until it was too
it's
late.
like when you
Yeah.
mispronounce nickel.
I don't remember that at all. What are you talking about?
What? You don't remember?
I don't remember this at all. Quickly, please. Quickly.
Fear in your
I
eyes.
can tell it. You're recording.
Okay.
Oh, yeah, that's right.
Oh!
Alright. So,
Good going.
what do most underdeveloped countries use biomass for?
Fuel?
Heat. Right? Heat specifically. Okay? Now, what are the health risks?
Oh.
No ventilation, which means you're breathing in carbon
Carbon
monoxide, and
yeah.
extra carbon dioxide, which is bad. It causes miscarriages and stuff like that too.
That sucks.
Keeping this going, what are the 2 major environmental consequences of biomass? Of using biomass?
I'm assuming like clear cutting occurs.
So yeah, we have clear cutting, which is not good, right? Because you're cutting down a whole bunch of trees, right? But then what else? What do we do with these trees once we cut them down?
We born or we burn them.
Burn it, which means
CO2.
CO2 goes up, right?
Yeah.
Very, very good. All right, ethanol is often produced from corn, which remember farmers produce in extreme excess,
Yep.
which can be used to substitute for fossil fuels. The problem that while it is carbon neutral, it doesn't produce a whole lot of not good thing. Energy. It doesn't produce as much energy as fossil fuels. Remember, when that stuff's underground, whether it's coal or fossil fuels, the longer it is underground, the more concentrated the energy becomes. Okay, so coal hasn't been concentrated yet. It also takes up a lot of space because you got to do what to make it?
Have space to have it.
To grow what?
Corn.
The corn. You have to have space for the corn to grow, right? Photovoltaic cells are used for
Solar panels.
solar panels. What's the difference between active and passive solar systems?
Active is like you're using the energy to transform into like electricity and like
Yeah.
It's
Sitting there just
soaking it in.
soaking it in, right? Active means you're directing. You're moving something. You're either moving water, heated water from here to there, or you're moving light from here to there, right? They can reflect those mirrors to that one little spot and boil that water, right? To make steam. Now, some drawbacks include expenses and impact on desert ecosystems. That's an interesting one I see over and over again. Is how solar panels can affect desert ecosystems. Let's say that we do cover a quarter of the Sahara with solar panels. What does that mean for the life in the Sahara?
They'll be fine. They'll make it.
There are plants that live there, and if you put these up, what will they do?
They're gonna die because
Yeah, the shade. The shade from the solar panels can cause environmental problems for the creatures that live there. Because if you kill off the plants, then guess who can't live there?
Animals.
Animals, right? So that's kind of an issue. If you had to pick an issue, this is one people will harp on, and I've seen this come up multiple times. So how can solar panels negatively affect ecosystems? By blocking out some of the sun. Yeah. Now, why should we try to put solar panels in the desert anyway?
Because it has the most space.
More space,
And
The most sun.
more sunlight. Remember, the reason we call it a desert is because there's very little what?
shade.
Rain. And what causes rain?
That's right.
Where does rain come from?
Clouds.
Clouds. Okay. If you remember when we talked about these currents, you remember the Hadley cells? Hadley cells. Where the Hadley cells go up, you get rainforest because as that warm, moist air goes up, rain comes down. But where it comes down, it's dry and cool and makes a desert. Okay. So you don't have many clouds there, which is nice. How does that's why we use it there because then you don't have the clouds blocking the sun.
And is that why it's cold at night?
That's why it's very cold at night. In fact, it's the water vapor in the air. If you've ever been in South Georgia, you know that it's so humid here that at night it feels the exact same temperature it was in the middle of the day. Because it's still brutally hot because the water is up. Water is a global warming gas, as we'll get to later on, water vapor. It actually heats the planet up too. And so deserts don't have that, so that's why it gets so cold. All right.
Still said well.
What, in reference to what?
Water to the water?
Water vapor was a.
Water vapor is a greenhouse gas.
Then we're screwed up.
Right.
No, greenhouse effect is good.
Screwed.
The greenhouse effect is good.
It's just the fact that we're
It's too much.
yeah.
We'll get
We're
to.
speeding the process up.
It's all about balance here. Anyways,
Yeah.
how does hydroelectric work?
You produce electricity by water.
Moving the water.
I don't know.
Okay. You put in a dam, which makes the water level go
Dang.
up, which increases its amount of what energy? As things go up.
Potential.
It gets potential energy. Now, the more potential energy it has, the more it can convert into
Kinetic.
kinetic energy as it moves down and spins the turbine, right?
Spin that
So you
turbine.
hold it up, spin the turbine, make the electricity.
Yep.
Now, what is tidal energy?
Shoot, I just read about this.
Keep in mind, a lot of the things that I'm talking about here with ethanol, you probably only recently heard of, right? Tidal energy is kind of new. Do you know where all these things here come from?
The
Do you remember when we did our self-teaching thing, where you guys had to teach your units? Yeah?
oh.
There's a lot of stuff.
left that
A
out.
lot of stuff left
I
out.
only know about
A lot of stuff left out. So because of that, we're having to do a whole lot of extra learning here today. But I think it's not too bad because we have a general idea. But keeping on here, what is tidal energy? Because that was in the standard there someone was supposed to teach you. So what is tidal energy?
I'm assuming they use the tides.
Yeah, what do the tides do?
They
They go in
And
and they go out. And as the water goes in and out, it has kinetic energy, which you can use to do what?
To come to electricity.
Spin a turbine. Exactly. That's the whole goal here, right?
Sure.
Yes. Building dams is expensive, but what are some consequences of building one for the environment? If I do build a dam, we have built one up here. What are the consequences of doing that?
The wildlife.
The flow.
The wildlife,
Yeah.
The flow.
the downstream depends on what? The flow of the water, right? If you put up a dam, you're decreasing that flow.
Flow.
Okay? Yeah. And so doing that, in fact, that river that we have over there next to the downtown area, has it gotten bigger since they installed the whitewater stuff?
It looks weird.
Does it look bigger now? Is it smaller?
I haven't bothered.
I haven't been down there when the
smaller than what it used to be?
Because of the dam.
I don't know what
Because of the dam?
I don't know
Yeah.
because
So,
I haven't seen it when the dam was
They've
up.
affected the flow of that river, and what's happened now is further downstream, we have different types of animals who are now able to succeed. Right, different types of fish species and bird species. Some of them can come back who hadn't been here in a long time because it actually gotten a bit too much. So it can have consequences, some good, some bad. But either way, you're gonna mess with stuff downstream. Who here's seen Frozen 2? Okay. What was the problem with that when they put that dam up there? Do you remember?
Well, wasn't that like community that was like down? It was actually bad for them.
Yeah, so further downstream, the community lived there. It was bad for them, and it caused issues, which is why the whole thing was cursed.
even work.
The whole thing of Frozen 2. It's a
I
big
watched
curse
the
caused by this.
Vanilla movie.
But
It had somebody down.
Couldn't hear you.
Okay, that's good. So
That's good.
That's good.
Keep in mind though too, if these dams break, what does it mean for the people downstream?
Yeah, all done.
Yeah. Okay, so there can be some consequences there. But you either restrict the amount of water there, or by taking it down, you add too much water there. Either way, you're messing with the environment. Geothermal energy works by running what underground? The whole goal of electricity is to change.
Water into steam.
So what do we run underground?
Water.
Water. Where underground, where it's hot.
Hot. And it turns
Yes.
it into steam.
Turbine.
And it turns into steam. Okay? And the nice thing is we can use that steam to turn turbines. Now, it is prohibitively what?
Dangerous.
Expensive.
Expensive.
Right, we've only ever drilled, the deepest I think is about 2 miles under the crust. 2 miles down is about it. Now, the crust is about 80 miles deep at its thickest and 50 miles deep at its thinnest. So we've barely even cracked the surface. Keep in mind, the crust of the earth is like the skin on an apple compared to the apple itself. So we've not even come close to getting down there. And it's prohibitively expensive. And here's the deal, when you do dig down there, you can release toxic gases like hydrogen sulfide.
Yes.
You guys know what hydrogen sulfide is?
No.
Yes.
Yes?
I don't.
Wait, I've heard of it.
If you've ever been to Savannah or any of those places on the coast, you'll typically have this water when you get it from the faucet that smells like rotten eggs.
Sulfur. That's sulfur.
Yeah, it's got hydrogen sulfide in it. And it goes out, you have to actually, if you don't want that smell or that taste, you have to leave the cup of water out for like an hour and let it evaporate out of solution. And then you can drink it.
No,
I know
see
that.
that? Okay.
But you can drink it the way it is, it's not too bad. But it is a toxic gas,
I'm
which is
good,
great.
love.
Now, let me see. How do hydrogen fuel cells work?
Oh Lord.
Okay.
It's like they have. Oh shoot.
You got it, Samsung.
Don't they make water?
Okay, it takes water.
They have hydrogen and oxygen. And
Or
then
does it make water?
What?
So you make water or take water?
It makes water. That's a
Cool.
whole product.
And you do it with what? What do you use as a fuel?
Oh, you can use fossil fuels, right? To
You got
power
fossil fuels to kick it off, but what do I need to make water? What two things make water?
hydrogen, oxygen.
Hydrogen and oxygen. You need hydrogen and oxygen, right? And your fuel cell, you combine them to form
H2O.
H2O.
Yeah.
But the problem is getting them to